Okay, so the last thing we're going to be doing for limits is the infinite geometric series. This is about 95% review from Math 20-1. So even though you're probably going to have forgotten the formulas once you see them again and we start using them, it is a 20-1 concept, but it does work nicely into limits, right? Because when we're doing infinite geometric series, that's when n goes to infinity. Now, a geometric series. Now, first of all, a series is when you add them up. Okay, a sequence is when you just note the positions. So when we're adding up a geometric series, we have to know, first of all, the first term, and we have to know what r is. Now, r equals what we call the common ratio. And the best way to find out the common ratio is take Tn and divide by Tn minus 1. In other words, take the fifth term and divide by the fourth term, or the third term divide by the second term. Okay? As long as you're taking the term, divide it by the one before it. And make sure you test it in a few places, and you'll see why when we do an example later, because some of them don't start as geometric series. They'll do a couple numbers and then the series starts. Okay, so you got to be aware of those. The sum of terms of, well, this example here, we'll just talk about this one. A would be 4, right? And R would be 40 over 4, which is 10. Okay, that's all you need to do. Once you have that, you can find the sum up to a certain point by using the Sn formula, which is a to the r to the n minus 1 all over r minus 1. I'm pretty sure that's on your formula sheet. Now, if r equals 1, which isn't much of a geometric series, but it would be still classified S to n equals NA. Okay, now people usually go, what kind of series would be that? The series would be 5 plus 5 plus 5 plus 5 dot dot dot. Okay, okay, dot dot dot. Okay, so that you would just take the number of terms and multiply by 5. Okay, but it is theoretically a geometric series because your r is 1, and it's going to make the next number the same. Okay, now infinite geometric series. Now you can only find an infinite geometric series when r is less than 1 or greater than negative 1. And one was like that on your quiz today, the one that went to 0. But when you have a sequence that by the end, every little number that gets added on is so small, it's not changing the total, your sum doesn't change. So there is a point that when your r is between negative 1 and 1, that those n numbers stop making a difference. Okay? If r is greater than 1, those n numbers keep getting bigger and bigger and bigger, so you're never going to be able to find the sum. So that's why we have to always be very careful to make sure we have found r. And if it asks us, what would be the sum of this to infinity, find r first, because if it's greater than 1, you would say that it doesn't exist. Now, the way we get the formula, because it's a nice formula right here, s to infinity just equals a over r minus 1, or 1 minus r. But the way that happens is from the formula. Now, you want to be writing this down, because even though proofs are not a big part of 31, They are a big part of first-year calculus. So to be able to see proofs, at least in grade 12, it's not so foreign when you get to university. In university, you're going to have to know how to actually do them on a test. In Math 31, you're just going to have to be able to understand them. So now remember, this is a limit as n goes to infinity. Now if r is between 1 and negative 1, r to the infinity would equal what? We had it on our quiz today, 3/5 to the n. It does equal 0. So this would be a times 0 minus 1 all over r minus 1. So you need to know yesterday's limit or today's quiz limit to be able to understand that. Then that's just negative a over r minus 1. Now, it sort of looks like the one I circled below, but not really, because that is a positive a. But if you multiply by negative 1 over negative 1, you get a over negative r plus 1, which is the same thing as a over 1 minus r. Okay? So the formula for an infinite sum when r is between 1 and negative 1 comes from the series formula that we always have been using. Now, if there is a r greater than 1, or sorry, less than 1, and greater than negative 1, we say that is convergent. That means that it is converging, okay, that it is getting smaller and smaller and smaller. To dissect or diverge or divorce or whatever that you want to put that word in, it means to split, to get bigger, 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 okay? So if it is greater than 1 or negative 1, the sum does not exist, and that is called divergent. Again, you should sort of remember that from grade 11. So the way I think it, divorce, bad, therefore can't figure out the sum. I'm not making any judgment calls. I'm just saying that's how I remember it. Sometimes divorce could be good. You never know. Now, I don't want to beat these to death, so let's just do example 2, just so we can use the formula that you learned in 20-1 is how do you find the sum of the first 5 terms. Now this one's pretty lame. If it was me, I would find the next term and add them all up in my calculator and I'd be done. Okay? But when you have to find the first 20 terms, that's not so efficient. So I'm just going to use an easy example to show you how to use the formula. Now you kind of want to gather all your stuff. You got a is negative 2. You got r would be 4 over negative 2, which equals negative 2. And always test a couple. 16 divided by negative 8 is negative 2. Okay, it is a nice geometric sequence or series all the way through. Now, do you see how this says find S5? Okay, not T5, but S5. So even though there isn't plus signs there, they do ask you to add them together. And then n equals 5. So S5, meaning the sum of the first 5 terms, equals negative 2 times negative 2 to the 5 minus 1. This one's a little bit confusing because a and r are the same. Okay, now when you multiply all the top together, you get 66. When you multiply the bottom together, you get negative 3. So the answer is negative 22. Now just be very careful when you put these in your calculator all in one shot. You want to make sure you put a set of brackets around the top and a set of brackets around the bottom, or you'll get an answer that isn't right. Okay, now find S10 for 5, 5, 5, 5, 5. Okay, now since R equals 1, all you have to go is S10 equals, or I'm going to put the general formula down, sorry. Sn equals Na, S10 equals 10 times 5, which is 50. Okay, so it says, for the above examples, state whether the sequence, so I guess we would be saying for the below more than 3 examples, state whether the sequences are convergent, divergent, and find the infinite sum. Okay, so A, is it converging or diverging? Okay, it's converging because R equals 2 over 4, which is 1/2. Okay, so that's what's really going to tell you. If it's less than 1 and greater than -1, you are convergent. Okay, then it's just a matter of putting it in the formula. S equals A over 1 minus R equals 4 over 1 minus 1/2 equals 4 divided by 1/2, which equals 8. Okay, so when you add that up, I know it's going to be 1/2, then it's going to be 1/4, then it's going to be 1/8, but when it's 1 over 3062 or 1 over 10 million, it's not adding to the sum anymore. Okay, so this starts to lose steam after a while, therefore it's not adding to the sum. So if you kept adding that up, it would equal 8 and it would never get larger than 8. Okay, B, convergent or divergent? What's the R? 4 over -2, which equals -2. Oddly enough, that confuses some students, right? They're thinking it is less than, greater than -1. Actually, that's less than -1. So we want to make sure that if it is not a fraction, it is divergent, and you won't be able to find the sum of that. It keeps changing every single one. Okay, C, would that be convergent or divergent? R equals 1, so that's divergent. It must be less than 1. Okay, sigma notation. I just want to talk about that. But to do that, let's do example F first, because kind of went to extreme examples right off the bat. Let's just do a simple sigma notation so you understand how every number works. Okay, so you got your little sigma. Sigma means add them up. Okay, that's Greek for add them up, sum. If you ever use like Excel or whatever, and there's a whole line of numbers, if you just darken them in, they have a sigma button at the top. You just hit it, and it'll sum it all up for you. That's why Excel is actually a pretty nice program. So if you had to do, let's do, say, n equals 1 here, 3, and then n squared is the equation I'm going to use. Now all this gives you, we usually call the, well, not usually, we call the bottom the lower limit, and we call the top the upper limit. Most times they're going to be integers, and all that is saying is put in 1 into this, put in 2 into this, and put in 3 into this, and add the sums up, or add it up and get the sum. So that would be 1, actually I'm going to use round brackets, 1 squared plus 2 squared plus 3 squared. So n in the sigma keeps replacing n in the equation until you run out. So until the top caps. Now you could start from n equals 5 and then put an 8 on the top. So you put 5 and then you do 6 and then 7, then 8. Okay, and then you just add them up and you get 14. So it's a really efficient way of saying add all these equations up. Here's your lower limit, here's your upper limit, add them up. Okay, so with that, then you can see how D and E are infinite equations because the lower limit is 1. It says, hey, go to infinity, find the sum. Okay, so is D convergent? Well, first of all, what you always want to do is you want to find out what would the first three terms be. Don't just do the first two, but what would the first three terms be? So you want to put in 1 first. Okay, so you're going to put in 1 here. 1 minus 1 is 0. So the very first term would be 4. Okay, now you're going to put a 2 in here next. So 2 times, that's 1. So 2/3 to the 1 is 2/3. 4 times 2/3 is 8/3. What's that? Because this is 1 minus 1, which is to the 0, which makes all this equal 1. Yep. Okay, now 3 minus 1 makes that squared. So that's going to be 2/3 squared, which is 4 over 9. 4 over 9 times 4 over 1 is 16 over 9. Now, until you do this, sometimes you're not going to get the accurate R. Now, this one's really nice because it actually took the brackets and put R in brackets. That's AR to the n minus 1. But maybe it'll be n squared plus 3x, or 3n. And then you've got to go find the first three terms to find your R. Now, if you take 8/3 divided by 4, or 16/9 divided by 8/3, you will get the answer. You will get R to equal 2/3. And then you just go and use your formula. S equals A, which is 4 over 1 minus 2/3. Okay, and if this thing kept going forever, it would equal 12. Okay, so I think the next one is a good example of don't take for granted just by looking at it that R would be a half. Okay, I think most people, after doing D, would go, I got to figure it out. R is going to be a half. But obviously I've set this up already. It's not going to be. So let's see why. Now if you put 1 in there, so you're going to put a 1 in here, that's 1/2 squared is 1/4. Now if you put a 2 in there, okay, 2 times 2 is 4, that's 1/2 to the 4 is 1/16, and then the next is 1/64. Now if you take 1/16 and you divide by 1/4, that's the same thing as 1/16 times 4 over 1, which equals 4 over 16, which equals 1/4. So this is what R equals, 1/4. So there's a very good example where find three terms before you just jump to conclusions and say, oh yeah, R's a half, because you are going to get an obvious different answer when you put it into A is, so my S is A is 1/4. That's a nice way to find A as well, over 1 minus 1/4. Okay, this one, A and R, are the same. And you will get the sum 1/3. Okay, example 5. Find the sum of this. Now, first of all, can we find the sum of this? What's the R? No. Because if you look at it, 1 divided by 3 is not 2 over 5. One third. But then 4 divided by 10 is not 1/3. 3 divided by 4 is not 1/3. Okay, so this is obviously a higher level question when you start doing these, but this, the series doesn't start till here. So in this case, you're going to have two parts to it. You're going to have 14 plus the infinite sum. So you really got to watch out for this, because I think to make this a really tough question would be to go 4 plus 10 plus 3 plus 1 plus, because people would go, it's going up, divergent, cannot find the sum. Okay, so check a few places along the line, and then this one's a little bit weird. Like, why they always give 3? Why in this one are they giving so much more? Because they have to give 3 of the pattern. So they're giving you more because that's the pattern came after those other 2. So 14 plus this infinite series, right? So that would be 14 plus 3 over 1 minus 1/3, which is 14 plus 9 over 2. That's 4.5, so you get 18.5. Okay, find the values of x that would make the series converge, and find the expression for the sum. Now, what's the r? Okay, so to find the r, take t2 minus t1, so that would be 3x minus 4 over 3. So r equals x minus 4. Now, what do we know about r, though, if this is to be convergent? We know that r has to be less than 1 and greater than -1. So with that known, I should be able to say this statement. Now you have two options how you can do this one. You could split it up into two equations, like what does x have to be? Okay? Now, you could split it into, well, x minus 4 has to be less than 1. And you can read it the other way, right? X minus 4 has to be greater than -1. And probably this is going to make the most sense to students. So then you just, I'm going to add 4, add 4. X has to be less than 5. I'm going to add 4, add 4. X has to be greater than 3. So then you can just write it out. X has to be less than 5 and greater than 3. A faster way to do it, now that you've seen this, and maybe is you can just, in this first equation here, you can just add 4 to everybody, and you would get the same equation. So if I add 4, add 4, add 4, I'll get 3x 5. I want to show you both ways, because with the little shortcut I showed you kind of makes sense after you do it the long way. So that's the first step. We have found what that must be between 3 and 5 if that series is going to converge. And then the second part is, well, what would be the formula for it? Well, we know the formula is Sn equals a over 1 minus r. So you put that in. A is 3 over 1 minus x minus 4. And you can simplify that just a little bit. 3 over x, or that's going to be negative x plus 5 plus 4. So that's 5 minus x. The 1 and plus 4. Yeah, I multiplied the negative sign into the brackets to give it a plus. So this would be your equation. And as long as x is between 3 and 5, you will get convergent. No, this one asked, and find the expression for the sum. Okay, now this you have done as well in 20-1. But it says write this as a geometric series. Now, this is 0.23 plus 0.0023 plus 0.000023 dot dot dot. Okay? So writing out the first three terms helps you understand this. We know A, obviously, is 0.23. And what would R be? Well, you want to take 0.0023 and divide by 0.23, and you'll get the answer of 0.01. Okay, it's multiplying by 100th every time. What's wrong, Jordan? No, it's good. Okay. So you can find your sum to infinity now. Would be 0.23 over 1 minus 0.01, which gives you 0.23 all over 0.99. Okay, you can move the decimal over 2 on each to get 23 over 99. Okay, just a couple, example 8. There's a couple tricky ones in the homework, so I'm like, well, I might as well do examples on it. So this one here, the only difference to this one and the one before it is that you're just going to have to go 1 plus 0.267 plus 0.000267, right? So this is the geometric series. Make sure you add 1 to it at the end. I don't think we have to go through all the rest. Just make sure you see it's similar to example 5. Now this one here, this one just messes with people's heads. So I thought, okay, let's do this one. 0.9 repeating. Okay, you want to write this as a fraction. Okay, so well, this is 0.9 plus 0.09 plus 0.009 dot dot dot. Okay, so R equals, or A equals 0.9, R equals 0.1. And if you're like, oh, do you just look at it and get that? No, you can go 0.09 over 0.9. It will give you 0.1. That's why writing them out kind of gets your bearings, and then you can just go from what you, as long as you wrote it out, right? Now, this would be 0.9 over 1 minus 0.9. Oh, 0.1. I was giving away my answer already. So that's 0.9 over 0.9, which equals 1. Okay, so therefore 0.9 repeating equals 1. Okay, that's the closest fraction you can make. Okay, and you guys have your assignment on the bottom page, so you're good to go.